Thanks a lot, everyone, for attending this session. And this session is really about, every time, whether you're getting into data science or you're already a very experienced data scientist, right? One of the questions that we often ask people is, hey, what makes you successful, or what makes you good, or what makes you super efficient in doing what you're doing, right? And you're able to deliver really successful data science project, right? And we spend a lot of time at my company, right, talking to some of the top data scientists in the world and spending time with both internal and external data scientists to say, hey, what makes you special, right? And how can we distill or crystallize a lot of the learnings that you have from all the data science project, right, into 5 essential skills that can help all of us as a data science community, right, move forward. So this is what this talk is about. Now, just before getting started, just a little background about myself. About 3 years ago, we had this crazy idea. We say, hey, there's this new machine learning platform on Azure, and we really wanted to write a book that does not just cover machine learning, because there's already a lot of good machine learning books out there, but we wanted to cover a book that captures the use cases of leveraging machine learning, right? But more importantly, how can this be applied to this new platform? 3 years ago, it was just emerging. So we started the book in 2014 called Predictive Analytics with Microsoft Azure Machine Learning. And then the subsequent year, we updated it with the second edition, moving on to what is known as the Cortana Intelligence Suite. And then we say, well, writing books, as the community can attest to as well, right, is not really a really easy journey. It involves time away from work, weekends, as well as vacations, trying to finish a book. So I say, well, in 2016, we're not going to refresh it with the third edition, right? We want to take a break this year. But interestingly, about 2 months ago at one of my sessions, one of the guys from Korea came out and said, hey, last year you gave me a book on Azure Machine Learning, and now we have translated it to Korean, right? And the reason why I'm telling you this is not trying to promote the book, but more trying to tell you the journey that we went through in trying to share with the data science community what machine learning is, right, and how we can apply machine learning. And in this book, it actually captures a lot of the use cases. But when we look back at writing the book, one of the things that we reflected on was, well, the book is great. It covers the use cases of how you can apply Azure machine learning on a lot of the real world scenarios. But it doesn't capture this essence, right? This magical or this secret that all of us would have asked, right, on how can I do my job better? Or if I'm an aspiring data scientist, how can I get into this field of data science? And what really makes data scientists tick? So many a times, I'm sure a lot of us ask this question, right? Whether it was you getting to data science or you are already doing data science on a day-to-day basis, is how do I get started in data science, right? And today, how do we go about answering a question like this? Often you search, right? And today, whether you use Bing, whether you use Google, you say, how do I get started in data science? Or you can ask a question, how do I, or what are the secrets of data scientists? You get tons of information, right? The question is, how do you take all this information and synthesize this and crystallize this into that 5 essential skills, right? So hopefully this session will help you gain those skills. And if you have other skills that we do not cover in this session, right, feel free to tweet at Hex Data Science Superpower, right, and we will incorporate it in future talks as well, right? And of course, if you're already a data scientist, how do I get better at data science? And getting us quickly to, hey, you know what, we'll cover. Now, for those that's new in this area, we hope to share with you some of the basics of data science and some of the common terminology that's used throughout this presentation. If you are an aspiring data scientist or in your organization, you have to work with data scientists. Hopefully with this, you appreciate the work that data scientists do on a day-to-day basis. And a lot of the learnings that you gain from this session will enable you to work with them better. And the third thing that we'll cover is, well, how can you drive successful data science projects? Now, for those that's new to this area, what is data science, right? Data science is really a very good blend of various fields, right? From computer science to having a background in mathematics and statistics, to having knowledge of machine learning skills, or even you just being a subject matter expert. For example, one of the guys that I work with really closely, he's not a data scientist, but he has spent the past 15 years of his career, right, working with finance people, and now he's part of the data science team. And on a day-to-day basis, he works with the data scientists in order to develop, right, new financial forecasting model, right? And therefore, subject matter expertise plays an important role, right, in making it all work. And what we're trying to get to is, at the center, which we call the unicorn, or many people in the community calls the unicorn, what is this person there, right? What is this person that has the superpower that is able to integrate the learnings from all these different areas, right, and produce quality results? Now, some of the terminology we'll use would be, we're going to use a lot of discussion, we're going to have lots of discussions on what is training data, right? How do you take existing data and split into training and testing data? Many a times we'll talk about features, which simply means the individual columns in a data set. And for a lot of the classification tasks that we'll talk about today, we're going to talk about the label or the target that you're trying to predict. Now, in this whole presentation, every time we talk about a learner, what we're really referring to is a machine learning algorithm. We're going to have lots of discussion on feature engineering and data wrangling, and it simply means how do you manipulate the data, right, to come or get to the training data set. And we're going to have several discussions on how can you leverage or tune some of the hyperparameters for the learners in order to improve the quality of your results. So let's see some of this terminology in action, right? Now we have a very simple example here will be, well, the question is, what will be the stock price next week? And these are the different data that we have, right? Well, we could start populating a table or data set that looks like this, where you have a column that's the stock price, the date when it's recorded, what day of the week, right? Where are we getting the information from, right? And once you have this information, of course, then you can then predict what will be the stock price next week, right? And this is just a way to illustrate the different terminology. So everything that you see here, the black columns, this will be what we call features. By combining all these data sets into a single data set, this will be a process which we call feature engineering or data wrangling to get it to a form where we can present it to a learner as training data. Now, the next natural question before we get into what are the 5 main ideas that we want to share today would be, what are the kinds of questions that data science can answer? It ranges from how much, how many, right, which is a regression problem, or what category would something fit into? That will be a classification problem. Or what groups, right? What kind of customer segments can we have given this customer behavior that we're observing? That will be a clustering problem. Or, well, you know, this data value or this set of data value that we are seeing, right? Is it weird? Does it stand out from all the rest of the value? That becomes an anomaly detection problem. And the last one is something that we experience a lot when we get to many of the online websites when you buy something is, well, if I bought something, what are others who have bought this thinking about, right? That becomes a recommendation that you could use machine learning or data science to solve, and then presenting this as result to the consumer. So let's get started with what are some of the skill sets that will be useful, right? And we have observed whether it's as habits or whether it's as things that data scientists do on a day-to-day basis. And I think we started this whole 5 skill set with the first one being obsessed with data is super important. And to illustrate that, let me show you why is it important. It is important because many a times, given a lot of the data, right, that data scientists get to when they kick off a data science project, is your customers could be asking very vague questions. Things like, hey, what can predictive maintenance do for my business? What can my data tell me about my business? Or what should I do? Now, it is the role of a data scientist, right? And it is the role of a good data scientist to be able to help the customer evolve a lot of these very vague questions into sharper questions, right? Or more pinpointed questions on, well, can this be answered with a name or a number? For example, how many Model Q gizmos will I be able to sell in Montreal during the 3rd quarter? This is much more powerful as a question compared with what can my data tell me about my business? Or if it's a predictive maintenance case, which car in my fleet is going to fail first? Or which wind turbine is going to fail? Or which aircraft engine will fail? What is its remaining useful lifetime? Now, once you have this sharp question, then the next thing that you will be able to get to is, well, get data that's relevant to answering these sharp questions. For example, often a lot of data science projects started off with, well, the customer providing with data. It might not be the right set of data, or there's just simply not enough data. Now, to illustrate this, what you're seeing here is a manifestation of not enough data, right? You have this picture, it looks really vague, but you don't really know what it is. Now, by trying to help the customer move from the vague questions to the sharp questions, you are able to get it to a point where you can help them get the data that you need, where now you have slightly more data, the picture becomes slightly clearer, but again, it's still not enough to answer the questions that you desire. That is what we meant by being obsessed with data, because you will continuously go back and forth in an iterative process with your customer to get to a point where you have sufficient data and this picture is crystal clear. Crystal clear enough for you to do feature engineering, crystal clear enough for you to get to the training data set that you can start doing or using a machine learning algorithm to learn about or to answer or to have a model that answers the specific question that you're looking for. Now, we cannot stress enough the importance of being obsessed with data. Now, and as data scientists, we need to continuously be obsessed with data. And many times, being obsessed with data might require you to work with a subject matter expert, right? And together, you can get to a set of data that will be useful for you to do training, that will be useful for you to build a successful model. Now, the next part that we want to get to is, well, let's suppose now you have quality data that you can use to build your model. What next? What are some of the habits that drive some of the top data scientists in the world? Well, if you talk to many of them, many of them will tell you, we have a data science process that my team, my organization have refined over the years that allows them to be super effective when they get the data they need. Let us take you through what a data science process will look like. Well, you started off with working with the business to define an objective. This objective must be a sharp question. It must be a question that relates to the business and contributes to the customer's bottom line, or the business bottom line. Now, you'll see how important being obsessed with data is in this overall data science process, where you will want to access and understand the data. And once you understand the data, you understand where the data is coming from, pre-processing the data, right? Being able to add additional features to the data, being able to combine different data sets as part of this pre-processing phase is super important. Now you get to a point where you already have the data in the right shape. Then of course you will then take this historical data, identify which are the features and which are your labels. And once you have that, you will split this into two sets. One, the training data. Two, the testing data. And at this point, you will start training a model using any of your favorite machine learning platforms. Before you start scoring the model, right, and using the testing data as inputs, you will then be able to score the model and be able to evaluate the quality of the model that you have just created. Now, once this is done, you will then take a snapshot of the model that you think has a good performance for the business problem that you're solving, and you will deploy this in a production environment, right, where with new data that comes in, you will continuously make predictions. Now, this seems a very simple data science process, and there's many variants of it that's used in organizations around the world. But the point that we're trying to stress here is what many of the data scientists have spent time being effective and productive in all these different boxes that you see here, right? And more importantly, they spent a lot of time thinking about, well, building the model is not a one-time thing. Many a times with new data that comes in, you realize that your model might not be performing as well. And having this process help guide them on how they should go about retraining, or how they should go about going back to the very beginning of pre-processing the data and adding new features that might be useful in improving the quality of the final results. Now, at the same time, you have to spend time thinking about, well, each part of this is not a one-time thing that a data scientist or a team of data scientists will do, deliver, and then forget about it. You need to think about this whole process needs to be operationalized. Right? It needs to run on a day-to-day basis. It needs to run on a weekly basis. And what is the most effective way of operationalizing this so that a lot of the steps that you do as part of doing data science, as part of building the model, right, can be replicated, right, and it runs in a production environment on a day-to-day basis. Now, this process relates with being the earlier thing that we covered on being obsessed with data, where you have a sharp question, you have data that measures what you care about, you have data that's accurate, and you have data that could be connected, right? And you have lots of data, and that will allow you to answer the questions that you see below. Now, the third thing that I wanted to cover is also one of the, I think one of the huge differentiator between a new data scientist and a very experienced data scientist is over the years, many of the data scientists, because of the nature of the work, because of them solving hard problems, they have maintained and nurtured this toolbox of tricks. This toolbox of tricks enable them to be effective. This toolbox of tricks enable them to get from data to having a model in a shorter time relative to someone that do not have the toolbox of tricks. And today we're going to share with you some of these common things in the toolbox of tricks from some of the top data scientists, and hopefully this will get you started. You can choose to say, well, you know, I actually have additional tools in my toolbox, and you're willing to share the community, feel free to tweet at Hex Data Science Superpower, and hopefully as a community, we'll be able to grow this toolbox of tricks. And hopefully as a community, we will be able to progress the state of art in data science. Now, before I get into the toolbox of tricks, one thing that cannot be overemphasized is, yes, we could have very powerful machine learning algorithms, but feature engineering, the ability for you to add additional data or additional features, is actually a very important and often underrated step when you do data science. Right, and we're going to illustrate that in the next slide. For example, here you see a very simple data set that has 3 columns, referred to as column 0, column 1, and column 2. And here we are trying to do a regression problem where you realize that when we evaluate the quality of the regression model, right, we make use of a matrix like coefficient of determination, which ranges from 0 to 1. And in this case, you see that, well, just using the original data, we get a really bad model where we have a very low coefficient of determination. And of course, we recall, right? We recall that we have gone through various discussions that feature engineering is super important. And we start adding an additional column. In this case, we added a column that simply says, well, why don't we multiply the value of column 0 with the value of column 1 to give us this new column. Now, but as you can see, feature engineering is important, but feature engineering without the relevant subject matter expertise might not be as effective. In this case, this new feature that we have introduced does nothing to improve the quality of the model. If you compare this with the previous one, in fact, it got even worse. So the question is, well, you told me that feature engineering is important, but sometimes when you do feature engineering, it must be with the help of a subject matter expert. For example, in this case, because of some of the knowledge that a subject matter expert shares, they say, well, multiplication is really not a differentiator. What is more important is to understand the difference between column 1 and column 0. And therefore, what you should really do is to do the subtraction. And you'll see that because of this new column that was introduced, our COD improved dramatically to 0.88. Now, this illustrates the importance that feature engineering, together with help from subject matter experts, have a lot of implications in helping you improve the quality of the final model that you have. Other examples of feature engineering would be, well, maintaining rolling aggregates, identifying lag features for both short-term and long-terms, and all this combined together, right, would become the toolbox of tricks where, given a new data set where you build an initial model that was not performing as well, you should consider doing feature engineering. And there's already a lot of good feature engineering techniques that you can apply immediately that will immediately get you to good results. Now, the next natural question, especially for new data scientists, is whether you took a course in grad school or you took a certificate in a data science program. Often in a lot of the class exercises or as part of the capstone project, you work with data set that is for classroom examples. And many a times when you first get into this area of doing data science as your day job, there's often this shock about, wow, the real world data set looks really nothing from the tutorial data set that I'm used to. Well, it could be the real world data set that you're asked to do on your first project doesn't have a label and you're asked to do a classification problem, or the data set itself simply looks hard, right? Either the distribution is not right, you do not have the right set of values. How should you go about doing it? For example, if you look at all this data set that I'm listing on the screen, from aircraft engine failure to being able to identify fraud or fraudulent telephone calls, to being able to identify customer churn, what's common in all these data sets? Well, in a lot of these data sets that you see on the screen, they suffer from a problem which we call the minority class problem. Right? And many a times when you get from a tutorial data set to a real world data set, the minority class problem often manifests itself. And when you try to build a model that has a minority class, your model will not perform as well, and I'll explain to you why. Now, for example, in this case, you are asked by an airline or aircraft engine manufacturer to say, well, can you help predict whether my engine is going to fail, when is it going to fail, and when I should proactively maintain it. You do not expect the data set that they give you to have lots of failures, otherwise we have a problem. And in those data sets, you'll see a lot of cases where you have aircraft engine that do not fail for the next 6, 9, 12 months. And you only have very few examples of the aircraft engine failing, but yet you're asked to build a model to predict whether the aircraft engine will fail. Or to many of the customers, or many of the customers' behavior data set, whether it's in retail, whether it's in telecommunication, and you're asked to model or build a model that's going to identify the customers that will churn. And what we meant by churning would be, well, the customer switching from you to another competitor, or even they stay on with your service, they downgrade to a lower level service, and that could be a customer churning. And to a lot of the businesses, being able to identify customer churn is super important. But a lot of the data sets, again, will not have a lot of examples where the customer will churn. Well, if they have a data set which has lots of customer churning, then this business has a problem. And therefore, when you are faced with all these real-world data sets that has a minority class problem, you have a problem. Why? Because many of the learners of machine learning algorithms learn by looking at the training data that you provide. And as they learn, the learners are often biased towards a majority class. And in a situation where you have a minority class, it's not going to be able to classify the minority class properly, leading to a situation where the minority class can be potentially misclassified. But if you recall the business question that you started with, find me the customers that churn, find me the aircraft engine that will fail. Your task is really to get the learner to figure out that and being able to answer that sharp question. And therefore it turns out that, well, in this toolbox of tricks, there's a very simple way of solving the problem. One good way of solving the problem is to do it in a very clever way of oversampling the minority class, and also very cleverly undersampling the majority class. The question is, how much oversampling should you do, and how much undersampling can you do? And therefore, in a lot of the libraries, whether it's R, whether it's Python, or whether it's in a platform like Azure Machine Learning, many of the data scientists use a module or a library called SMOTE. SMOTE is a super useful technique which they have in their toolbox of tricks that does synthetic minority oversampling, right, of the minority class, right? And in this case, because they were able to boost out the minority class without sacrificing the original characteristic of the data set, you now have a training data set, right, that is balanced between majority and minority classes, and therefore you can build a model. Now, the next natural question that a lot of us will ask is, well, either we write a program like what was shown earlier in Scala, or whether you use a tool like Azure Machine Learning, right, to build an experiment. Many a times, one of the things that you'll be doing is, well, you say, well, I have my favorite machine learning algorithm, but I also want to make sure that I try out different machine learning algorithms to see which one of them produces the best model. Well, a rule of thumb is often use a simple model that you can understand. Use a simple model that allows you to run the experiment very quickly so that you can fail fast. But even after you've done all this, one of the questions that a lot of us will ask is, why am I doing so many iterations? Why do I have to try and error? And in many cases, many of the data scientists in the early stages of their career would be very systematic about their trial and error. They would capture, for example, if they use a decision forest algorithm, right, what are the different values that they use for the different hyperparameters of the machine learning algorithm. For example, if they use a decision forest, they might say, well, what are the number of trees in my forest? If they use a decision tree, they might say, what is the depth of my tree? How deep should my tree be? Or what is the minimum number of examples or instances I should have in the leaf node? But again, even after they have systematically do all this, it doesn't scale because there's only so many hours in a day or in a work day, and there's only so many experiments you can run. And therefore, you want to be able to smartly go through all these different sets of possible parameters, which can be combinatorically large, and yet being able to work towards a very common goal of either improving the AUC or improving the accuracy, improving the precision, or improving the F-score. There must be a smarter way of doing it. And it turns out that there is, right? So in a very simple brute force approach, we'll say, well, given a machine learning algorithm I'm using, I will create a grid over all the parameters or over all the hyperparameters. And then for each combination, I will run the experiment. Well, it turns out that some of this machine learning algorithm converges really quickly, and therefore they run really quickly. But some of this takes a long time to run. And many a times, this is also dependent on the number of features that you have in the dataset. If you have lots of features in the dataset, you're going to take a long time to run your experiment. You wouldn't want to get into a situation where you run your experiment for days, and finally it gives you a suboptimal model, and you're back to the drawing board. And it turns out that, well, can we have a smart way of enumerating and running experiments so that we can converge fast, but yet we can get to a point where you have a good model? Well, it turns out that you could do it, right? And today, there's a lot of approaches, and you have the paper below, which provides more of the details, is at the same computational cost. It is possible to select the parameters randomly in a grid, and this is a grid of all possible parameters. And by randomly selecting parameter in the grid, you can actually get to a good results. And it also turns out that by choosing 50, 59 random points from a parameter grid, this will actually guarantee you with 95% confidence that you will get to the top 5% of the metrics that you're optimizing for. Now, the implication of this is you can then do a random grid search over a span of 50 plus parameters or random points. And that will get you to a good initial baseline experiment, which is super impressive because then you do not have to have your experiment running long for a really long time, right? Because you could eventually cut the time that you take to run your experiment, but yet you're not worried that the quality of your experiment suffers. And in a lot of the very mature machine learning libraries, including Azure Machine Learning, you actually have the ability to do hyperparameter tuning by simply specifying what do you want to optimize for. Now, before we get into the next tips and tricks, let me just show you what I mean. So right now, what I'm showing you is one of the many machine learning platforms which I find really powerful is Microsoft Azure Machine Learning. And this is essentially a development environment for you to build your experiments. Now, while this is running, let me just show you a very simple experiment. So many a times we'll say, well, let's start off with a blank experiment. And let me call this ISA Summit 2016 0817. Now let's take a look at a data set. Now in this case, I'm going to take a data set which I call telco training data. And let's explore the data set. So if I right click and visualize, you will see this is a data set that has 29 columns and about 20,000 rows. And if you move from left to right, it has different characteristics about the customer from a telco perspective, including things like the call drop rate. Now, if I move from left to right, you'll see that this data set has a label called churn. But as I was telling you earlier, in this specific data set, this particular column called churn has two unique values, zeros and one. And if you look at this, it has a majority class and a minority class. But this minority class is exactly what we want to predict for. So if I were to build a very simple experiment, and I say, well, let me get a train model. Let me get a score model. Let me mark one of the column as my label. So I'm going to click and drag this. I'm going to launch a column selector. And I'm going to scroll all the way down and choose churn. Once I'm done, I've selected the churn label. I'm going to call this the label column. Now, next, I'm just going to do a very simple thing of splitting the data. Now, you realize that the earlier data set that I was showing you has the problem of the minority class. And I was telling you in the toolbox of tricks that a lot of many data scientists have is they make use of this implementation called smooth. So I could click smooth and drag it into this canvas. Let me connect this together. And here I will tell the smooth module that the model that we're looking for, or the label, is really Chen. Once I'm done, I'm going to close. And I'm going to say, well, let's boost out this by 200%. Right, Smooth allows you to define how do you generate the synthetic data. In this case, I'm going to say 2 nearest neighbor. So what I've just done is I've taken the telco data. I have looked at it and understand that there's a minority class. And therefore, in my toolbox of tricks, I have dragged Smooth in order to boost the minority class. And I've configured the Smooth module. Now next, I'm going to split the data into 70-30. And I'm going to say, well, my training data will go to the train model. And I'm going to indicate that for this train model, I'm going to ask it to train where my label column is Chen. Now, once I'm done with that, I'm going to click Close. And I'm going to select a machine learning algorithm. So I'm going to type classification. And here, you'll quickly see all the machine learning algorithm that we support. I'm going to use a 2-class boosted decision tree. Once this is connected, I'm going to say, well, let's train the model, right? And then we're going to score the model using the testing data. And finally, I'm going to evaluate the quality of my model. So I'm going to type evaluate model. And I'm going to drag this here. Now, what I've just done is a very simple experiment in a short time using one of the items in my toolbox of tricks, which is called Smoke. So I'm going to click Run. Now, at this point in time, the Azure Machine Learning Platform is running an experiment, right, using the 2-class boosted decision tree model, right, and it will eventually give you a trained model, which we're going to evaluate. Now let's wait a while for this to run. And we're going to get to a point where it's going to finish running the Smoke module. And we're going to see the effect of what Smoke does to the original data. Now, as this is running, let me see whether my earlier experiment has completed, so I can show you how it looks like. Well, it turns out it's still running. Let me find one that has finished running. And let me open this. The same data, but you'll see that the effect of me applying Smoke, and if I were to do a visualize, you'll see very quickly, if I go all the way from left to right, and look at the Chen column, you'll see that because I applied Smoke, my minority class has been boosted up. And this is what I use in the rest of the training. Now, if I go back to the original experiment, which should have already started running, you will see that it has also finished mode. And similarly, if I have to right click on it and choose visualize, and if I go from left to right, you will see the same observation that the churn column, the minority class has been boosted. Now, this is almost finishing running, and we're finished running the experiment. Now, I can look at the evaluate model and visualize my AUC. Now, you'll see that because this AUC is already pretty good, that's because we have boosted the minority class. But let's suppose you're not satisfied with this AUC that you're getting from this particular experiment. One thing that you'll probably do is you could say, well, let's try other classification algorithms. Say, two-class logistic regression, or we could say, let's use a support vector machine. And I could continue adding this, and I could do the same and I could, using Azure Machine Learning, I could very quickly add additional algorithms, and it should just work. And of course, I could run this, and of course, I could compare the different models and see which one produces better results. Well, or I could say, well, let's look at the different algorithms I'm using and change the hyperparameters. Or I could look at the decision tree and change the learning rate, number of tree constructed. But obviously, this is not very productive because I will have to continuously do this and I cannot scale. And therefore, I could easily say, well, I want to do hyperparameter tuning, replace the trained model, remove the trained model, and I could then drag the tune hyperparameter, connect up the same algorithm, give it the training data, and now at this point in time, it's going to say, what is your label column? So I'm going to choose the same churn label. And you'll see that because I'm able to say, well, I want this U to sweep in a random grid over 60 runs. And I can choose what metrics do I want to optimize on. Accuracy, precision, or the AUC. So in this case, I could say I choose the AUC, and I'm done. So what this Teal model hyperparameter will do, and this is also available in a lot of the R and Python libraries, is it will then help you enumerate over a random grid, right, over 60 iterations, right, a better model. And this is super helpful at times when you don't have time to do all the trial and error, or you simply want to scale up your effort. Now, this experiment is going to take a long time to run, and we're not going to wait for it to complete. But the point here is I have just used two of the items in my toolbox or tricks, which is mode and tune hyperparameter tuning, in order for me to effectively get to a good results. So let's quickly get back to the slides. And the last piece of this toolbox is, are there tips and tricks that enable me to get to a good baseline? Well, it turns out there is for a specific problem. For example, this is data that comes from KDD Cup 2015, 8 million rows, 7 columns, and the goal is exactly to predict customer churn. Well, the question is, can I be at the top of the leaderboard within the top 30 with my initial experiment? Well, it turns out you can. How can I build an experiment that will always be within the first 1% accuracy of the winning solution? Can I build an initial experiment that will get me to the top of the leaderboard? Well, in public contests, this is super important, but in your company, when you build a model, you want to get to an initial good baseline so that you have sufficient time to iterate on it. It turns out that you can. Using a technique called RFM, which stands for recency, frequency, and value, which is a very common technique for customer behavior modeling. I can do that. Now, if we map that to the KDD Cup 2015, RFM could relate to these questions that you can ask of the dataset. Now, let's see how well this performs. In KDD Cup 2015, there is about 800 plus entry. The final winner has an AUC of 90.9. And this is after 250 iterations of them submitting. And it is the merger of the results and the models from 9 teams. Well, if you use RFM modeling, which we show in the block entry that you see below, we got to an AUC of 90.1, and that was the first experiment that we run, and we are immediately within the top 26 place. Now, here we're not trying to brag that we are within the top 30 results. What we're trying to show you is by putting RFM in your magical toolbox of tricks, that allows you to get to an initial baseline for a specific problem of customer churn. Now, if we look at this and we summarize, we showed you in your toolbox RFM, we showed you how you can handle minority class. We showed you hyperparameter tuning. And as I was telling you, if you have new tricks that you think is useful to the community, please add it to Data Science Superpower and tweet about it. My alias Twitter handle is Wee-Hyong, right? And hopefully by us as a community growing the toolbox of tricks, this will enable us, right, to grow as a data science community. Now I'm going to cut this, and we're going to finish up the rest of the presentation. Now this leaves us with a question, which feel free to tweet about it, right, is can I auto-generate a machine learning model that has initial good results? I'll leave that as food for thought. Now, the fourth thing that we want to share is how can I learn, or more importantly, learning from all the experts, right? Not every single data scientist have their area of expertise, and therefore it is super important to learn from the expert and internalize. And it turns out that there's good communities out there. One of the community that has been very vibrant over the past 2 years is the Cortana Intelligence Gallery. Well, many people say, well, how can I get started in data science and learn all the skills that you're sharing with me in this webinar? Now, about 1-2 months ago, we just launched this data science degree, right, where everyone can participate in this and get a professional degree in data science. There's a lot of edX course that allows you to learn data science and some of the machine learning essentials. Now, the last piece that I want to share as part of the learnings is it is great that you get to a good initial baseline. It is great that you have this toolbox of tricks that allows you to be more efficient and productive. But you have to ask yourself, why are we doing data science? We are doing data science because we want to drive and improve business results. There is always a business value that as a result of you having a quality model that is operationalized, the business benefits. And therefore, the fifth things about cracking the data science code is after you have built all this, you need to get to a point where you can drive actionable insights. What do we mean? Well, you could have a dashboard that communicates the insight. Or you could create a web service and operationalize it so that other applications can consume the results of your model. Now, you could deploy the results of your model as a stock procedure, and today you can do it in SQL 2016 with R. Well, you could share this to with the community either by publishing your code on GitHub, publishing it in a gallery like the Cortana Intelligence Gallery, or you could simply blog about it, describe your results in Markdown, in a PDF, but more importantly, you can work with your business partners to make a decision, set a price, and all this will enable you to drive actionable insights. Well, to summarize what we have covered in this talk on cracking the data science code, we have distilled some of the habits and some of the learnings, right, from top data scientists within the company as well as outside of the company into 5 essential points. Be obsessed with data. Have a data science process that enable you to operationalize each step of the process easily, but more importantly, have a way for you to systematically tackle your problem. Now, the toolbox of tricks is super important. We shared with you some of these tricks, right? But you could grow your own set of tricks. You could share with the community the tricks that you have. Learning from the expert cannot be overemphasized. But more importantly, learning from the expert, internalizing a lot of these tricks, that allows you to grow your toolbox of tricks. And the last piece about cracking the data science code is to drive actionable insights. Now with this, I hand it over to the host. Thanks a lot for attending this session on cracking the data science code. Hopefully these 5 essential skills will enable you to distill the raw data in your company into actionable insights. Thank you everyone. I appreciate your time.